All right, let's talk about a word you hear everywhere in tech these days, microservices. If you've ever been in a class or just scrolling through job posts and thought, what on earth does that actually mean? Well, you've come to the right place. We're going to demystify this whole thing by looking at a company we all use, Netflix.
So let's just cut right to the chase. When you first hear the term microservices, it's totally normal to think, hang on, isn't that just a super fancy way of saying we're going to break one big thing into a bunch of tiny little things? And you know what? You're not wrong, but that's really just the tip of the iceberg. There's so much more to the story.
To really get why microservices became such a game changer, we have to kind of rewind the clock. We need to understand the world before them and the huge problem they were created to solve. And that story, it all starts with this thing called the monolith.
Okay, picture this. It's the early 2000s. You're still getting those red Netflix envelopes in the mail. Back then, their entire website, their whole business, ran on what's called a monolith. Think of it like one giant, tangled ball of code. Everything, your DVD queue, billing, the movie catalog, all of it was crammed into one single, massive application that talked to one single, enormous database. Everything was connected to everything else.
And this quote from one of the Netflix engineers at the time, Josh Evans, man, it just says it all. Because everything was so tightly wound together, if one tiny part of the system had a bug, say, the part that updated your shipping address, it could take down the entire website. For everyone, a total blackout. For the people actually building this thing, it was a waking nightmare. That same engineer, Josh Evans, talks about a single tiny memory leak that took his team more than a week to find because the code was just this massive, tangled mess. And what if you wanted to add a simple new feature, something as basic as adding a new column to a database table? It became this huge, all-hands-on-deck project. It was slow, it was super risky, and it just couldn't keep up with Netflix's growth.
So, you can imagine the frustration, right? And out of all that chaos, a really powerful, simple idea started to form. What if the problem wasn't how they built the application, but the fact that it was one giant application in the first place? What if, instead, you built lots of small, independent ones?
Now, here's the official textbook definition of a microservice architecture. It's a little dry, let's be honest. It talks about a suite of small services and lightweight mechanisms. So, what does that actually mean when you're not writing a textbook?
This is where it really clicks. With that old monolith, you had one giant blob of code. If you wanted to change one tiny thing, you had to rebuild and deploy the entire house. It was this huge, risky, all-or-nothing event. With microservices, you have lots of small, focused services. The team that works on the search bar can update their own little service and deploy it all by themselves without ever bothering the team that handles billing. They're independent. Heck, they could even be built with totally different programming languages if they want. I think this is the best way to think about it. The monolith is like a simple amoeba. It works, but everything happens in one place. If one part of it gets sick, the whole organism is in trouble. A microservice architecture, though, that's more like a human body. You've got a heart, you've got lungs, a brain. Each one is a specialized organ that does its one job really, really well. And yeah, they all have to communicate to keep the whole system running, but the failure of one doesn't immediately take down all the others. Okay, theory time is over. Let's pull back the curtain and look at the actual organs inside the Netflix machine that you use every single day. So the next time you open up the Netflix app, just remember you're not talking to one thing. You're actually communicating with hundreds of these microservices all at once. There's a service that handles your account info, there's another one for search, there's that super smart one that figures out your recommendations, and of course there's the one that actually streams the video to your screen when you finally hit play. Each one is its own separate little organ.
And the skill we're talking about here is it's mind-blowing. Let's take just one of these hundreds of services, a little one called EV Cache. Its only job is to temporarily store data to make things faster. Well, it handles 30 million requests. Not a day, not an hour, every single second. There is just no way a single monolithic app could handle that kind of load without completely melting down.
But, of course, there's a catch. There's always a catch, right? If your application is a complex body with hundreds of independent organs, what happens when one of those organs gets sick? This new way of building things doesn't just solve problems, it creates some new and pretty tricky ones.
This is where you run into a really dangerous problem called a cascading failure. It's basically a domino effect. Let's say the service that creates your personal movie recommendations suddenly goes down. Your app asks it, hey, what should I show on the homepage? And it just gets silence.
So your app waits and waits and waits, tying up resources. Eventually, it just gives up. But now, because that one little piece is missing, the entire homepage might just fail to load. One small failure just caused a huge outage.
So that's the million-dollar question, isn't it? How do you protect the whole system? How do you stop a problem with one organ from taking down the whole body? This was such a huge problem that Netflix had to invent its own solution.
They built this amazing tool called Hystrix, and it works exactly like an electrical circuit breaker in your house. When Hystrix sees that a service is failing over and over again, click, it trips the breaker. It just stops sending requests to that broken service. No more waiting, no more cascading failure. But, and this is the brilliant part, it provides a fallback. So if the recommendation service is down, instead of an ugly error page, Hystrix might just give you a generic list of the top 10 on Netflix. You might not even notice something's wrong. The app still works, and the broken service gets time to recover. It fails gracefully.
Okay, so let's zoom out and put a bow on all of this. We've seen the old, clunky monolith, the new, complex world of microservices, and the challenges they bring. So why on earth would companies like Netflix go through all this trouble?
Well, it all comes down to a few huge advantages. It lets small teams own their little piece of the universe and just move incredibly fast. It lets you scale only the parts that need it, which saves a ton of money. You get resilience, that ability we saw with Hystrix to survive failure. And all of that adds up to the real prize, speed and agility. The power to innovate and ship new features for users, fast, without risking the entire application. It's not just about breaking things apart, it's about building a system that's designed from the ground up to survive failure.
So, microservices solve the big problems of the monolith, but as we saw, they created their own new set of complexities, which naturally gets you thinking, what comes next? What's the next big idea that will solve the problems created by microservices? Because in technology, nothing ever stands still. Today's cutting-edge solution is just tomorrow's problem to be solved. Pretty cool to think about, isn't it?